I wanted to provide a little demo of the current state of the Media Station Preservation Project, as I'm calling it. The ultimate goal is to be able to play these Media Station titles on modern hardware natively and not need some sort of x86 emulator like, running Windows 98 or something like that. And the first thing that I needed to do was see if I could understand how all the asset structures worked. And so, I currently have a Python application. As you can see, it's a pretty large Python application that takes in all of the CXT files from a Media Station title and then exports all of the assets that it finds in there. So, to give you a demo, I will just run that. It's running on Dalmatians, as you can see. There's a lot of debug info going on because I'm currently trying to understand the bytecode for the scripts, the media script compiled bytecode. And so that's kind of scrolling past in here with this debug output. I'll show later how some of the stuff I got has been super helpful in helping me understand this. Alright, so you can see we're decompressing everything, we're applying the keyframes to each of the movies and so forth. You can see the asset names scrolling by. So we have a directory structure. Each of these CXT files is a folder. And so we're looking here, we opened up 127.txt. And so each of the static images, as you would expect, let me change this so we can see it a little more easily. So here's the background for this screen. Each of the static images, as you would expect, is just kind of exported like it is. Each of the movies, each frame is exported as an individual BMP, for instance. And the sound is also exported as well, separately. So that's basically where I'm at right now, and that might sound rather trivial, but really it required going into each of these CXT files with a hex editor like this. And for these headers, which are specified by these IGOD IDs, I still have no clue what those actually mean, but they specify headers for the assets as opposed to the actual data. Figuring out what each and every one of these fields means, what each and every one of these bytes means. So for instance, I figured out pretty early on that there is a typecode system where, every value is actually preceded by a typecode, which I'm highlighting here, that specifies like the size of that value. So 0300, or 3 if we're interpreting it as Little Endian, which this in fact is, means a 16-bit integer. So we interpret it as that. And I call these things datums. So basically, to just be able to export those assets, be able to understand all the bounding boxes, all of the hotspot stuff, which is a different subject entirely, and all of the dimensions and all that sort of stuff, I had to understand all of these fields in here. Which just looking at it just kind of looks like, random data. What in the world is that? So with a lot of concentration and a lot of time invested, I was able to figure out many of those fields, which is pretty cool. And then, of course, then you have, if you scroll down, you get to the actual asset data. For the background, it's easy because the backgrounds are uncompressed. So I also had to figure out the compression format, the transparency stuff for movies and the sprite movies and so forth. And then also the audio, which was not as difficult because most of the audio wasn't compressed, aside from like some recurrent audio, which was in fact compressed with IMA 80PCM. So all of that knowledge is kind of baked into this Python application. You can see I have this C module here that handles all of the decompression for each of the bitmaps, including handling the transparency and applying the keyframes if there's keyframes. Here you can see this is like the master asset object. So we have like all the different asset types that I know about, including some odd ones. Here I'm listing out all of the fields that can exist in an asset that I know about. So all the possible fields and then so forth, yeah. Then if we go to context, this has all the logic for reading the palette, reading the headers in the context or the screen, reading the bytecode, which is something I'll get to in a moment, and then reading the actual asset data. So it's kind of like building multiple levels of abstraction to provide a human understandable way to grapple with what just kind of looks like super overwhelming binary data. So something that has been super useful is a former Media Station employee was able to give me some Golden Masters and asset archives. And the Golden Masters were interesting. There were some titles I didn't know about that Media Station had made in there. But what was even more helpful than that was the asset archives. Specifically, I'm going to open this up in this tab over here. Specifically, there is listing out of each of the scripts that, apply to each object. So this specifically is for IBM Crayola. The asset archives for Dalmatians, although I did get those, they didn't actually have the MediaScript source code. This isn't like C source code or something, this is MediaScript that is compiled into what I'm handling here in this script object. And to be clear, this bytecode is not x86, 68K, or PowerPC machine code. It is bytecode specific to the MediaStation engine and interpreter. So the is like a virtual machine. The MediaStation engine executes this bytecode in its own environment and its own stack and everything, and it's not executed directly by the host processor. Basically, I had to interpret each of these numbers that you see as, all right, what operation is that actually doing? And that was nearly impossible to figure out what in the world was going on without having some sort of reference to look back at. And of course, the retail titles didn't have any MediaScript source code in them. All that was in there was this compiled bytecode for your event handlers, your functions, and so forth. So this was extremely, extremely influential in helping me be able to figure out, all right, what actually are these functions that are being called? We are reading out the compiled bytecode right here. So what's being read out in here is from the retail version of the title. There is no reference to this MediaScript source code that's over here. But this asset archive should be the same as, hopefully the same, as what is actually in the retail CD-ROM. There should be some correspondence here. And this is, in fact, exactly what I found. So let's see, so we are reading code for asset 861, which is the screen, and the first thing we do is we are assigning a value to variable 302, and the value is the literal value 486 plus the return value of the method height called on asset 1131. And looking at all those things, cross-referencing the profile.st with this, which has the actual asset names. Again, this is the source code that was not included with the retail version. This is the MediaScript source code. You can actually see, all right, that is actually exactly what's happening right here. So asset 1132 is this credits panel thing. Variable 302 is the height, and so forth. So basically, by painstakingly looking at what's in the retail title, comparing it to what I expect to see from the source code from the asset archive, I was able to very successfully figure out, all right, what exactly are all of these functions being called? What do they do? What are the event handler types, which are just numbers, and so forth. So I think that it's pretty cool that I've been able to go from something like this, which is utterly incomprehensible, by cross-referencing back to the MediaScript source code. I am able to then re-implement a parser for this compiled bytecode, which again is just a series of bytes. There's no human-readable semantic information in there until I impose that upon this. So that is the chief way in which the asset archive stuff has been really, really useful to me. And now that I am able to actually parse the bytecode, I can then re-implement an engine in ScumVM to be able to actually play these titles, not just export the assets, but actually play the titles on native hardware, which is the entire goal of my project from the beginning.